We'll get going in just a second. Sorry for the AC noise. I might turn it off. It's keeping up, but it's more reliably a long-term stream if I got the AC on. Hello, DCD. Thanks for coming. Still kind of arranging my windows here. Hopefully I didn't forget anything. Looks like YouTube's going. Restream's going. How's everyone doing? Hi, Sam. Thanks for joining. Hi, Beata. Glad you could make it. Get going in just a second here. Hi, Timon. Hi, Tyeth. Let's see. Sorry, I'll get going in just a second. Hi, Justin. All right, let's get going. Hello, everybody. My name is Scott. I work on Adafruit for CircuitPython. CircuitPython is, I said CircuitPython and I almost said the spiel for Adafruit. CircuitPython is a version of Python designed for tiny computers called microcontrollers. Here's an example. This is a feather. Oh, I picked one with a can. So here's a feather board here, and underneath this canister is a, oh, sorry, let me turn my audio to my headphones. Is a little tiny computer called the microcontroller. So this is a Bluetooth board. It's an NRF52840. So what we do is we have CircuitPython run on a device like this. You plug into the USB and you get a CircuitPy drive with a code.py file on it. And it makes it super easy to jump in and start coding. Here's an example. This is an example of what Adafruit does. So they make development boards like this. Hello, Deshibu. They kind of put the microcontroller together with a certain layout and other things on the board to make it easy to make different projects that you want to make with a microcontroller. So Adafruit is an open source hardware and software company based out of New York City. I work remotely for them, based out of Seattle. You can see it's a nice sunny day out here. I've got the window cam up here. So if you want to purchase stuff from Adafruit, you can go to adafruit.com. However, I think they're still in moving mode. So if you want something soon, I recommend ordering from a reseller until that banner on the website goes away, which I don't actually know. Let's switch to desktop and let's take a look. Yeah, it's still on the site. So just a heads up, they are moving from Manhattan to Brooklyn. So everything is in New York is kind of up in the air. So if you want to order something and get it fast, I recommend a reseller like DigiKey to get it sooner. Okay, so this is a deep dive. I do them nearly every Friday at 2 p.m. Pacific. Next week will be Foamy Guy. I have a long weekend with family, so I will not be here next Friday. I will be here the Friday after. 2 weeks from today, I will be back. So thanks in advance to Tim to doing deep dive. And yeah, so I love to answer questions. So if folks have questions around CircuitPython or Adafruit stuff, hello Fede2. Feel free to ask it. I'll do my best to answer, but I make no promises. What I have kind of in my brain for today is I pulled up these servo things because I've been thinking about a Lego sorter. So I got this servo for doing a pan and tilt head of like being able to take a bunch of pictures of a Lego and then tilt and dump it the direction I think it needs to go to sort it. So I was just putting that together for a little bit. But that's my brain's fried task. what I've been working on actually is CircuitMatter. So CircuitMatter is a Python-only implementation of, hopefully, of the Matter IoT spec. You may have bought, like, for example, the light strip behind me here. Matter devices come with these like QR codes that allow you to set up the device with your particular HomePod Mini or Nest Hub, that sort of thing, and kind of integrate into what is ideally a unified system for IoT devices. The website is buildwithmatter.com. So I've got the Matter spec here, and I'm re-implementing it kind of from the ground up in Python only, with the idea being that we can run it on CircuitPython in the future. Right now I'm running it in CPython on my desktop, but the goal is that it would be a slim, hopefully slim implementation of the Matter spec that we can then run on CircuitPython as well. So that we can, like, our pitch with CircuitPython in general and Adafruit's goal is to make things more accessible to people, making it easy to make devices that you would kind of see commercially, but be able to do them within like the homebrew hacker space instead. So I pitched the idea of just re-implementing Matter in Python only, largely because there's a canonical C++ SDK. So like there's a canonical C++ implementation, but bringing that into CircuitPython could potentially be rather large and maybe not used all that often. So if we do it in Python land, we can load it when we need it, and we can use it across anywhere that Python works pretty much. So that's why we kind of decided to try to do it again. A couple reasons I think that's not a crazy idea, and I covered this last week as well. The project Matter spec used to be called CHIP, which is Connected Home over IP. But they have both a JavaScript implementation and a REST implementation, and these are both kind of in that same vein of like re-implementations in a single language rather than just building onto the C++ version. So there's crazy things like it has its own like configuration language and stuff that it inherits from Zigbee and things. So there's a lot of layers to get this all working, and I'm just like working through those. So the layer I'm working on today is the cryptography part, the first cryptography part. So one of the reasons there's a bunch of layers is because of security, and really trying to do right with how secure things are. Now, that will not be true with CircuitPython because part of our goal is to make it easy to change firmware. And if you make it easy to change firmware on the like user side, you're not actually secure. So part of being a secure IoT device is actually making sure that you can't load others' firmware onto it, which is kind of wild, right? Because like if some bad actor actually had access to it, then they'd be able to hack you. So that's a whole nother thing. So I was hoping to find the, yeah, so if we see here, we did a lot of message framing stuff. I didn't do really routing, but we're kind of at this security layer now as we like work our way up this stack, which is kind of insane. But yeah, so I started by just saying I have a UDP packet. How do I parse it? And so that has to do with message framing and then decoding of the packet within the message. But there's only a few messages that get sent back and forth without being encrypted first. And that's where the security layer comes in. So this stuff doesn't really matter. I haven't really gotten there. So I'm looking at the architecture. Okay, so here we go, device commissioning. So device commissioning is the process of taking a new device and getting it to getting it kind of commissioned into what is known as a fabric. So talking to the HomePod Mini that I have testing, or I actually can run it commissioning to my desktop as well. Getting that kind of all established and so that you can work kind of in the future. So these are the steps for that. One is device discovery. There's an out-of-band secret, the passcode from a commissionable device's QR code, manual pairing code, and an NFC tag. And then that's used by a Pascode-authenticated session establishment to establish a secure commissioning session. So we haven't done that yet. So I'm on step 2 of many steps. Step 2 is establishing this passcode authenticated session. They are encrypted using these PASE-derived keys. The process also establishes an attestation challenge used during the device attestation procedure, which we are not doing yet. We haven't gotten that far. There's a lot of layers. Oh boy. I don't know how many more layers I have. Information configuration, joining the network. Security setup with case. This is certificate authenticated session establishment. And then you're on the network. But it's kind of overwhelming, honestly. So my goal for the week is to get, ideally, the PASE, the passcode authenticated session going. And so I skip from chapter 2 down. I skipped chapter 3, which is cryptographic primitives, which I did read and did not find that helpful. Because it just refers out to a lot of stuff that I don't really understand. But if we go to session establishment, passcode authenticated session establishment. So this is the very first packet that we're getting is a PBKDF parameter request. I've successfully gotten us sending the response, and now I'm getting this PASE contribution. I forget what PASE stands for. Augmented Password Authenticated Key Exchange. And then the reply, and then you get a verification, and then you're done. So I am successfully receiving this PASE contribution, and now I'm trying to reply with our own contribution and the verification, and then we'll get a verification, we'll be done. That is the higher level what I'm trying to do. So what will happen, I suspect, after this is done is that it'll start talking at an even higher level about attestation and stuff. I haven't gotten that far. I just want to get to the point where this verification passes, which is going to be kind of hard. So there's the structs. So we did TLV encoding last time. I think I'm successfully encoding and decoding these structs. So I'm getting a PASE1 struct in and trying to reply with a PASE2. And it goes in a lot of detail. So it has step-by-step instructions. So we are not the initiator. The other device is the initiator. So it's doing this stuff. It's figuring out PA, putting it in this struct and sending it our way. And then we say, okay, once we get a PASE1, first we have to compute PB using the values responder stuff, using a verifier. And then we do this transcript of the session, and then we do more cryptography, and we fill in PB and CB back. LDR FBS, larger fibs? Hi from Sweden. I hope I don't, well, I know I put people to sleep. So I hope if anybody falls asleep, you sleep well. If anybody knows cryptography better than I do, I'm hoping to find somebody to help me with this stuff too. Okay, so this is where I'm at. So, okay, I receive a PASE1. Now I call this crypto PB, and then crypto transcript and crypto P2, and then I reply back with this stuff. And I feel like I can do the reply. I just, this crypto stuff is new. So if I look for crypto PB, it's late here over the pond. Yep. Thanks for joining anyway, Dishipu. Not that one. Oh, sorry. Gotta wrap around. I usually work on the side while watching. All right, that's all good. Okay, so here it says, PB is an uncompressed public key format as specified in section 2.3 of this. And it shall be computed as specified in this thing. No sleep, more science. Rai got my OpenThread module compiling, but it's crashing for memory access. That's tricky. Probably a bad pointer or something, because we're in C land and we still do that. So it kicks out to this spec 2+ thing. And then for a transcript, which is also something we're going to do, they talk about, and this double or this double bar is not or, it is a concatenation, which they do tell you somewhere in this thing. But yeah. Okay, so we do this transcript, and I think the idea is that the transcript is the same. PA, PB, KE. So I've filled this all out. Here's the C source, because part of what I'm doing is I'm putting debug logs in the other end of it. So let me, okay, so I built it. I've actually got the code running here. We can see this is the PASE2 reply that we did. And then we get a status report that it failed. And here's our PASE1 and the PASE2 that we send back. They're random bits, which is, helpful, I guess. But at least like our TLV encoding seems to be working. Although I'm going to jinx myself with that. Okay, so I'm going to run, I figured out how to do, before I was using my phone to like initiate the commissioning process with my Apple HomePod Mini, but that's a black box. And so I realized that there's this thing called chip tool, which is kind of like around that C++ library that is kind of the like canonical SDK, the canonical implementation of it. So I can run chip tool, say, hey, I want to pair with something that's on the network. I want to give it the ID 1, and this is my passcode. And I can run it, and we'll see that the same thing happened. We failed again. And we can see failed to verify peer's MAC. This can happen when setup code is incorrect. So I double checked my setup code, and I think it is right. But these two things are just debug prints. I wanted to see how far it got. So it is computing around 2, given a key confirm, but it's then failing the key confirm thing. So I think what happens is that there's some data that's shared between the two things that they both kind of encrypt with different things, different private keys that they can then verify or something. I think that's what that transcript is like there's this public record of like back and forth of what they do, and they use that as the like shared thing that they're going to do more on. So what I was thinking is that I could print out those values to make sure that my computation is the same as the default's computation of it. And maybe that will help. I don't know. So we are in key confirm. We did not get so far as to say that key confirm OK works. And then this is tricky. I don't know where this key confirm is. Okay, here we go. Source crypto, chip crypto pal. Chip crypto pal. And then key confirm. Okay, so what it's doing is it's saying confirmation keys. I don't know what KAE span is, but then it runs the key derivation on oh, this is generate keys. Correct. Is this maclet as in HMAC? Yes, it is. So I have like a HMAC thing that I'm calling. Okay, so I'm slightly off because I need to be I think we are the prover role. I don't know what that is. That's probably a password of mine for something. I don't know what it's for though, so good luck. Prover. No, I don't want that. That's a time where like I'm getting a thing I don't care about. So Mac verify is what is failing because we are getting this. Point buffer, point size. Point right, we take an X or a Y. And we write it out. Like, size. Let's do, we'll just do the first two hex characters and see if those are the same. Let's see if that works. And this is my gripe about this. The only way I know how to build it is to call this install script, which does way more than just rebuild chiptool, but I don't know exactly why. Oh yeah. I have this big 2+ thing open too. It's right here. And this has all these different A's and B's, and you can see I'm like literally searching for P's to figure out what P means. Like, it's succinct, except they don't, like, I remember yesterday, I think I was like, what is H? I don't know what H is. Like, it's a letter. Like, they don't say what H is in this at all. It's just very jargony. Like, expecting you to have like a bunch of background that they don't actually tell you we expect. Okay, so point size, we are the prover. Point size is 65, so it's probably a control byte plus other stuff. And if we look here for an 04 for A, but there's also, yeah, PA here is 0445. I hate that this type of code is still a thing. This like authentication stuff, like, yeah. Like, I even dropped in the like Python cryptography IRC channel and was like, how do I do like elliptic? Like, I had to figure out that some of these variables are actually like points on an elliptic curve. Like, I just thought that was all numbers. It's just not clear at all. It's like clear as mud. Oh yeah, whole naming variables as a single character. Yeah, for sure. Drives me nuts. Drives me nuts. Okay, so let's go back to the source and see. So we think this is X, which is also PA. I have no idea what you're doing, so the guess is H for hint. Oh, so I think I figured it out. Maybe I didn't. Turns out I'm doing elliptic curve cryptography without actually understanding that I'm doing that. So I guess I should take a little bit of a step back. H in this expression is known as the, I can't remember. If we look in my code, cofactor. H is the cofactor. H equals the curve cofactor. And then you multiply by that. And there's like X and Y are like the decoded versions of the like point on the curve. And then PA and PB are like the byte encoded version, and they have to tell you like what encoding is used for that. So I think maybe what we should do is we should just double check this crypto transcript thing. So let's, well, TT. So I think the crypto transcripts should be the same. So we both have PA and PB. Z and V are different. Oh, and like the library I'm using for this point math doesn't have subtraction, so I add the negation of it something. It's just, yeah, so this is a very, very, very deep dive. Sorry. Length of bytes of the context, and the context is a hash of the context prefix, the parameters request, and the parameters response. So maybe we just verify, let's verify that I got that far. So that's what this digest should be. So this is context. Let's make sure that our context hash is right. Let's kind of like follow through and make sure our computation's the same. This should be the same because the 3 elements that go into the hash are the same. So we'll restart. We will rerun this, and we should get a printed out, but let's print it out better. Yeah, so we're in the weeds of cryptography, and I don't know what I'm doing. I was bound to get to this world at some point. So let's do the corresponding. See, with the C++ stuff, I don't know how to just do like this, print this byte string out as hex, like, which is one of the reasons I really do like Python. Is like, Python makes it very easy to do those sorts of things. So, compute round 2. Verifier, peer verifier. Regular verifier is what we're computing here. Verify is computed in compute round 2, and compute round 2 lives in here. Compute round 2. I think that there is a internal hash, internal hash, internal hash, generate keys. Mac probably means multiply and accumulate. Maybe. No, maybe it's HMAC. So these point writes and internal hashes are the ZVW0, which is me. That's it assembling the transcript. I think. Point buffer in. We are the prover. Internal hash. I am definitely out of my wheelhouse. Write M and N. Begin verifier. Pure identity, my identity. Begin prover, my identity, pure identity. What I'm expecting is I thought you take the digest of internal hash. What is hashed? Oh my goodness. Crypto stuff. How is it not? Oh. Can you tell why my brain has been like I do 3 hours of this and then my brain's just like, you're done. My brain's tired. Internal hash of context length. Oh, okay, so speak to init. Context, commissioning hash, finish. This is what I want. Hash is go to x 0. We'll just do the first two. Because it's probably like get hashes where like if the first two are the same, then you're probably all the same. Okay, let's try that. So complicated. It's like installing pip and doing all this stuff. This is the only way I've managed to build chiptool. I couldn't do it directly, I couldn't figure it out. It's like so complicated. Point size. Context hash is 89 and 07. Okay, so this is not the same. The pain of learning something new sometimes, yes. All right, so our context hash is not the same. (43 CB). So like you gotta start back at the start, right? Let's add a third one. And now let's just chase it down. So this M commissioning hash is how we're hashing things. Maybe my hash function's not implemented? Can I print a byte span? See, I haven't done C++ in a while either. So let's... No. M commissioning hash. Ah, come on. I don't know what this is. Byte span curly brace. Can I print it out, do you think? I don't know what byte span is. I bet I can do... Start of 0. So that is param response. That is not something we even... I don't think this will be called. I picked the spot to add it first. The So this code has both directions in it. Ooh, there's a log byte span. Thank you, 404. Log byte span. Module category byte span. Okay, let's try it. I think that's right. I think Copilot got it right. Not quite. I was trying to avoid just use GDB, but yes. Oh, I don't want a GDB. Handle parameter response. I think this is called. Let's try it. Well, I think I've got it all implemented. So I'm hoping kind of like Plinko is that like you start from the start and you fix it up until it doesn't work. Did you mean this? Sure. I feel like I'm out of touch with C++. Can I say using? I think that'll work. It just I've had such bad luck with like their like I think I said a few weeks ago that like debug insecure channel. Made that up? Secure channel is not. What do you think chip log detail is? It just took me to the namespace. Oh, come on. My brain is. There's log byte span. Okay, let's just do. Oh, I'm not surprised. They have some strange preprocessor stuff that generates and wraps that. Oh, I'm shocked. Ah. Internal log byte span impl is category enabled. Oh, yep, I think I got where you're linking. 404 says, why? Yes. Let's try this. It's all this like turning things off and on. Just so much stuff. It gives me the same feeling as I get whenever I do JavaScript. It's just like so much complexity. Chip log bytespan was not declared. Lab support logging, binary logging. It's just like this thing done by a lot of people that have been working on it forever. Pass 3 arguments but takes 2. How did I give it 3 arguments? Let's see if that's what it wants. Hopefully by me putting in the time with this, like, will make it easier for other people to actually use Matter. Like, that's the benefit that we bring to the party. I don't know. Sorry, I don't know how to use this garbage. It doesn't make any sense to me. I'm gonna do it myself. What happened? I gave up because I couldn't get it to compile because their stuff is too complicated. Simplicity is a benefit. And this is anything but simple. It's layers and layers of complexity. Still doesn't work. Response was not declared in the scope. That's my problem. Like, why is it so complicated? I'm making a light bulb, a secure light bulb. Well, theoretically secure. Like, I tried to get it compiling and I had to install Perfetto, and it's just like, this is ridiculous. Okay, it worked. And we ran again, and now we've got hello world, param response, 15, length 120. Okay. The first byte is 15 and the length is 120. So let's find the equivalent of our code to do this, which is exchange commissioning hash, update, application payload, copy, print, first. Actually, I kind of like that. No. That's not what I want. I want 0 and the length of it. Let's just do it in hex. It's going to be like I guess I could do it. Okay. And then the last commissioning hash thing is here. I actually expect the lengths to be the thing that varies. Because 15 is the way structs start. Okay, so back here, 15, 120. And if we look for our commissioning hash stuff, 30 and 118, that is not right. That sounds very suspect to me because it should be 120 long. My guess is that there's an outer wrapper that I'm not including, but I should be. So I wonder if I do encoded, but I'm just gonna hard code it here just to see. I got a little excited thinking maybe this is the one thing. This is the thing I need to fix, and then it's all just gonna work. Yeah, right. Failed again. Context hash is D0FC72. I should stop printing out all this stuff. D0FC72. Yeah, I saw the Python Matter server. It's not actually done in Python. It calls out to the C++ stuff, I believe. I don't think it's like ground up Matter stuff. Okay, so our hash is right now. Where is that? I shouldn't remove our prints. Context D0FC72, and then if we look here, D0FC72. So that was why our hash was wrong. So our hash is right now. But we still fail verification. So what do we need to check next? we could check the length of the transcript. I think it just gets hashed. Crypto P2. It's entirely possible, like, I'm gonna go to this and it's not gonna make any sense. Okay, so let's print KAKE hex. And we'll also print the length, or I guess we're already printing the length of that. Let's turn off some other prints, because we're printing a lot of things. Print page 1. Bit of a fight about C++. This implementation is not completely Python, right? Implements a Matter controller server over WebSockets using the official Matter SDK as a base. Right. Like, and then it links out to the C++ thing. So it's like, it's just Python wrapped around it, which is the other way to do it, but yeah. Trying to do it without that, which we'll see. Okay, so we're still printing the messages out. I should probably turn that off. Receive pick 1. Transcript is 534 long, and this is the hash of the transcript, 8923 CB. So let's see if we can't find in here in crypto compute round 2 internal hash point buffer generate keys hash finalize into KAE span. So that is what should be the same. Hi GM20, we're figuring out how to do cryptography for that. Oh, and I pasted Python into there. Trying to compare cryptography implementations. Chip log detail. Hey, that'll work. Let's see if that works. I think they should be the same, if I'm not mistaken. Maybe not, but I think they should be. Although Z and V are computed differently, so. But I think I've said, I think it calls it a shared secret, which I assume means it's the same. 5C E9. 5C E9. And this is what that's getting. Transcript is 534 long. So if we pull up the spec2 stuff, let's say parties A and B compute Z and V that are now shared as common values. Party A computes this. Party B computes that. And ZV should be the same? Context is an application-specific customization string shared between both parties and must precede the remaining transcript, which we think is the same. That's the hash of the first stuff. Upon completion of this protocol, A and B compute shared secrets KA, KE, which is what we're trying to compare, KCA and KCB as specified in section 4. And then CB and CA are ways of confirming that it went all as planned. Both parties, the protocol transcript TT as defined in section 3.3 is unique and secret to A and B. Both parties use TT to derive a shared symmetric secrets KE and KA. So KA must be the private key. A and B output KE is the shared secret from the protocol. KA and its derived KCA and KB are not used for anything except key confirmation. Oh, how much brain power do I have until I give up? Using the cryptography stuff builds on standard stuff and just need to know what the flow they implement. I know, but I don't know that. Like, I'm trying to implement the spec2 stuff, and I don't know how to recognize these are like the underlayers, right? And the cryptography library should have the higher layer on it, but I don't know how to interpret these things and kind of back it up to the higher level. But I think, I mean, this suggests that Z and V should be the same on both sides. KA, KE. Here, 5C. 5C E9. So that's a hash of TT, which I thought TT should be the same. Can it tell me? Oh, there's hash. I don't know what that is. Chip log detail. Crypto. Can I do dot? Can it tell me how long it is? I love this stuff. I really do. Yesterday I actually worked on the stemma G0 stuff and made progress, which is neat. That is much more up my alley on this stuff. Stream. Begin, add data, get digest, finish. Oh, you can get an intermediate padded digest for it. Oh, you know what? It looks like add data should be implemented here. No. Where's it implemented? I think it's here. PSA, embed TLS, open SSL, host. I don't know which version I'm using. Probably OpenSSL. Chip CryptoPal, OpenSSL. I'm gonna put a log. What's a byte span? Or it was length, right? I don't know. All these types that I don't know what they are. What is a byte span? JNA type wrappers. Live support span. That seems promising. Fixed span, regular span. In here. Bytes to hex. Wait. Byte span is a span of uint 8. So if I look at what you can do on span, subspan, there's a standard span API. Operator, oh, it is size. Let's see if that works. Sorry, folks, this is definitely in the weeds. I feel good about getting the hash rate. Any questions? Somebody want to ask me a question where I can go on a tangent that's not this cryptography stuff? I'm at least happy that this doesn't clobber my changes. Okay. I wonder if I could verify that the verifier needs to be the same. I probably could. Okay. Okay, this is pretty handy, actually. Well, a little handy. So the 8s are sizes. The 65s are data. And the 4s are the starting value. So the equivalent for my code is the transcript function, this. Print 8 and TT of offset as a hex value. And then print length of E and hex. I'll just print all of E. E.hex. And we'll print offset as well. Eight 65, 865, 865, 865, 832. And then there's 2 more here. Let's add 2 here. No. Here. Hey, I picked the right one. This is kind of how this whole endeavor is gone. Of just like progress slowly, like consistently making progress, but so not getting super stuck, but also like it's complicated. So we did new prints here, so we're going to do that. Start it over, we compiled, and so we're going to do another pair. And we could actually also print the digest as we go, which would also give us some idea of if we start in the right place or not. Context, and then we do 20. I wonder if I could I make this the side tab? Oh, that'll work. Can I drag it back in? I'd like to get them side by side. That's okay, I guess I can. Thanks for joining me for this in the weeds thing. Okay, so 8 to 20. You know, let's print the hash. At least the start of the hash. Because we just found that we can do get digest into immutable byte span. Should we do that? I know how to do it in Python. It's kind of annoying. Well, let's just compare these first. So we do a 20, 8 long. We do 32, E1, 77, E7. The length is right. 8 zeros. 8 zeros. Ah, see, this says, no, this is index 56, 8, and it starts at 41. And then we do 65. 65 length, but it is 04D8. So the order of these is backwards. This is running locally. GDB, another vote for GDB. I'm like such a print debugger though. So it looks like my X's and Y's are backwards. Does that matter? I guess we just flip it and see if it works. Oh, this is M and N. We haven't even gotten to the other ones yet. N and M. Let's just try it. Failure. So we did oh, they did 480. 88. A2E2, 19.3E. Did I restart this? No, I guess it was backwards. I guess GDB lets me step through one at a time. Okay, 488, 4D8BB. And my lengths are 8 and 65, and then I do another 4, 1, 10, that's correct, and then I do another, and it's 4, D, 5, 9, that's correct, 4, D, 5, 9, and then 4, 6, C, 2E, that's not right. 4FF. Decorate and explode the types nicely. Yeah. So it's my Z's and my V's are not right, but I'm not sure whether they're supposed to be the same. I imagine they are, because I imagine they're supposed to be identical through the magic of cryptography. Does that make sense? My Z and V are different, and then this last number, W0, should be the same, I think. And it is not. It is not the same either. See, the funny thing is that I'm loading that from a file. So the last three numbers are different. And then my output is different. But I think it's supposed to be the same. But I'm loading W0 and L, I load. But I would expect W0 should be the same between the two. Like the verifier here, W0 and L. Let's find W0 in here. I think that's the verifier. Pure verifier. Compute run 2. I know there's a W's thing. Compute W's. Serialized W's. Begin prover. Compute for local, for W, 0, and L computations. Okay, so I think W, 0, and L should be the same. Ship log detail. Perfect. M is a serialized. Yeah. So I should be able to will it guess right? No. W0. Equal to no. See much right? I got that far. Sorry if this is driving people nuts. This is how deep dives go. Ask me questions if you want me to get out of this funk. Ask me something else if you want to watch me do something else. Okay, let's try that. I'd love to get this working by the end of the week. There's the chip pairing code. I took it from my info that the provisioner thing generated. Let's see, I wonder where. It didn't print anything. So this must not be called. I feel like we found where it was called though. Oh, compute W's versus generate. installs it. Here we go. I see your question. Hopefully you'll be encouraged in picking up some open source software. It's often the case that one or two key pieces of information missing and must be determined before one can just run with it. Glad that CircuitPython isn't as difficult to pick up. We look forward to the CircuitMatter implementation providing the missing key to Matter. I sure hope so. I hope we can like demystify it a bit and make it easier to homebrew. Obviously, that's my goal. I also don't know how. There we go. B422. There's our. This is our code. And B422 and then yeah, I mean I hope so. W2 here doesn't have anything of the sort. C310 2C. I wonder if I have the wrong verification stuff. So where I got it from here. So there's the expressive matter stuff will generate a code for you. So this is the code. See, it's under passcode is this. That's what I'm handing in here. That's the number that we see here. And then in the summary, there's no passcode in this file, but the discriminator is the same, and this setup code is the same. 1019, same here. And then there's a verifier, which is this. It's before product label. And it should be W0 and L concatenated together. And it is copy in CircuitMatter device state verifier. It's the one that I have in there. Is my salt wrong? My iteration count wrong? My discriminator is different. Is that part of it? I don't think it is. Maybe it is. Where's that file that had the discriminator in it? 1983. I don't think it is. Oh, and it's in the wrong. Did I change it? I might end a little early because, one, my brain is fried. Let's see if I did change it. And I gotta pee. Discriminator changed, salt changed, and the verifier is gone. Why is the verifier gone? Right, the verifier should have it should be constant. There's no random number that goes into this. It's a 10,000 iteration count. You know what? There's this script. Actually, maybe what I'll do is I gotta go use the bathroom, so I'll be right back. I'll be quick. Let's just not. Let me bring my keys so I don't get locked out. Okay. Oh, and I zapped it. Sorry for the, I don't often have to use the bathroom right now, but I must have been drinking a lot of water. Okay, so there's this, Python file that can generate this stuff. I think it's spec2p.py. Yeah. So I bet I can reintroduce it. Salt of length 16 to 32 octets encoded in base 64. So Python copy paste. Iteration count is 10,000. Passcode is up here. Oh, come on. Ugh. Here's the salt. Passcode is Oh, that's not the right. So stupid. Subcommand. One thought, are there acceptance tests that verify the original Matter SDK is working? Already verified that in comparing against SDK demo, right? I have not. I assume it is. Okay, I think. Okay. I got some output that is not what I have from my verifier, but if I run it again, I get the same thing. So how did, is this wrong? No, I got the same result. I wonder if that works. Copy. Device state verifier. It's kind of a long shot. Still failed. W0 is still B422. And here it is. Where did I print it? D311AA. Is that the same? Did I just... Am I not? To me, it feels like there's got to be some sort of a mismatch, because I think this should be the same. Maybe not. But I thought W0 and W1 are the same thing. Make sure we're loading the right file in, the right value. Maybe hard-coded it. No. 0xGQX. J blah de blah. D311AA, but over here it's B422. Maybe like the salt is wrong, or I think they should be the same. Because it's a function of this thing that takes passcode, salt, iterations. And then you mod them both by the same number. And this should be a stable thing. All right, I'm just about toast. Sorry, this has been a deep dive. It's not always like this. Come back. Little endian setup pin code. Byte span salts. All right. Let's verify that input. Chip log detail. Secure channel. Iterations. Salt length. And 0. The data. Because I do. Okay, that looks right. I am sending it those things, and maybe I'm sending it wrong. Maybe it's doing a different number of iterations or something. Python environment conflicts. Now it's not working. It's no longer building. Oh. Does it work here? No. It used to work. Oh my goodness. I know this talking about build systems, like I don't need a bash script. Not everybody uses bash. I'm using fish. Write a Python script. Python. You've got some Python, just do all Python. I don't know what I did to break this. I did do that. Like I'm using it within CircuitMatter because I've gotten the chip stuff to work that way. Bash install was working earlier. Did I accidentally change something else? I can't walk back and get history because I don't have... When did I change Bootstrap? Oh, I did change Bootstrap. Did I change it? stopped working. Maybe I should have committed it. PW command not found, line 22. Pop very context. Bootstrap line 139. Did I change it somehow? This is so ridiculous. I don't know what I changed. I just tried it in a clean window. In the wrong place. Well, that's frustrating. I can't even do what I used to be doing. All right, I'm gonna wrap up. I gotta cuss. I gotta rant a little bit. Actually, I gotta go home and clean up cat puke. But you know, I think I'd rather go home and clean up cat puke than keep dealing with this stuff. Oh, maybe I'll commit at least. I didn't make a lot of progress. I figured out the hash thing. So I made one small step. I don't know why my builds stopped working. It's shell stuff. I'll tell you, I was doing a little bit of the stem and G0 stuff yesterday, and having just a Python build system worked quite well. I'm pretty happy with it. All right, yeah, I'm gonna get out of here. Okay, everybody, thank you all. It's been a slog working on this cryptography stuff, but thank you for all your support. Preemptive thanks to Foamy Guy, who I see in the chat, for deep diving next week. I will not be here. I will be here back in 2 weeks, just out next week. So stop by for that. It'll be more exciting than this. It's a low bar. If you want to support me, you can do that by supporting Adafruit, going to adafruit.com, purchasing hardware, although it won't ship right now if you buy from them, so you can buy from resellers. I work on CircuitPython and CircuitMatter now, and yeah. Thank you all. I'll see you all next week. Well, next week on Discord for the first 3 days, and I'm out Thursday, Friday. And then I'm around all the week after that. So, yeah, support me, adafruit.com. Buy some there. Good night, LGR FPS. Thanks for sticking around. I'm very surprised. Names I don't recognize that stuck around. Thanks to DCD for taking time codes. And yeah, I'll try to push this code just so I have it backed up, not just on this computer. So, thank you all. Have a great weekend. I will talk to you on the Discords next week. Oh, Discord link is adafru.it/Discord. Good night. I'll do window cam, and I'll get out of here. Thanks all.